Welcome to part 7 of Senior Developer in 24 Hours. My name is Andres, and today we're going to continue talking about automating the build. In the previous video, we started going through the different phases, the different steps we can take to automate the build in a sensible and thoughtful way. We talked about component metadata. We talked about picking a sensible and useful versioning system. We talked about making the tool chain available to our developers. Today, we're going to continue down the same road. We're going to keep going down the list. First, we're going to talk about dependencies. Then we're going to talk a little bit about code compilation, running our tests, running our checks, and publishing the artifacts that we produce. Now, with that said, let's dive into the dependencies. First, let's ask ourselves a couple of questions. The first one is, do we really need to have fully reproducible builds? What does this mean? It means that for a certain revision in our source code, we are guaranteed that building the artifacts is going to result in the exact same artifact down to the bit level. Sometimes this is the desirable outcome. Sometimes we need to be a little bit more flexible, and I'm going to go into a little bit more detail soon. The other is whether the libraries that we depend on are present in the same repo as the application. For some companies that have implemented a mono repo pattern, they might choose to have the dependencies as source code in the same mono repo that is hosting their applications. This is not very common, but I just wanted to mention it because we are going to focus on the other case where we normally pull down the dependencies from some kind of repo, some kind of artifact registry. All right, so let's keep in mind that sometimes we're okay with builds that are not 100% reproducible. In some cases, we want to have easy access to the latest versions of the libraries. Why is this? Because we want an easier way to integrate changes from other teams into our application. If we're working side by side with another team, this other team is building a library that we depend on, and they're making constant updates. Sometimes it makes it easier for us to just have our build system configured to pull the latest version that the other team is working on, rather than having to, bump the library version every time our peer team makes any kind of changes. So how does this work? For example, if we're working with Java, we can use what is called snapshot libraries. This is relevant if we're using something like Maven or Gradle. They use basically the same mechanism. And the idea is that a snapshot artifact precedes the actual release of the artifact. What this means is that, for example, 1.0-snapshot is version 1.0 under development. So as the team progresses, they get closer to 1.0. They keep updating the 1.0 snapshot artifact. We can refresh it, and we can get those changes as they're coming down the line without having to constantly bump up the version. Now, obviously, the downside to that is that today's snapshot library or artifact might be different than yesterday's. So if we're building it today, we might get a slightly different result than what we would have gotten yesterday. The advantage is that hopefully today's version is a little bit further ahead, less bugs, more features, closer to 1.0. Now, with that said, this is an approach that should be taken with some caution. In particular, snapshot dependencies should only exist during development. Once we're ready to go into production, once we're getting to actually release our component, we should move away from snapshot dependencies and use the real artifact that has actually been released and that is fixed for a particular version. Also, it is recommended to not rely on snapshot dependencies that are not developed by your team or organization, because you don't know how far along they are in their development. You don't know how far along they are to actually reaching that milestone release so that you can get rid of the snapshot, which can introduce a lot of uncertainty in your process. And finally, as I mentioned previously, snapshot dependencies can cause the build to be not reproducible. What does that mean? Every time we're building, we're rolling the dice a little bit to see what kind of result we're going to get, depending on the status of the snapshot library. And this is especially true when the snapshot library is in the early stages of development. They're making significant changes, things like that. So it adds an extra level of risk to the build. But overall, it improves the experience and improves the workflow of the developers. So it is a very useful tool, but it must be used with care. Now, what happens if we're using other languages? Languages other than Java or related JVM languages. So, for example, some of the other languages or ecosystems have something that is called compatible libraries. If we were to be talking about pip and Python, we can use the tilde. So, for example, tilde equals 2.2 is going to get us any version that is greater than 2.2. If we do something like tilde equals 1.4.5, then we're going to get any version greater than 1.4.5. So this is a way for us to get libraries that are at least at a certain level, but it is also going to allow us to quickly and painlessly get the latest patch or the latest library with a greater minor version. If we're using something like npm in the Node ecosystem, we can use the caret to accept minor and patch updates, or we can use the tilde to accept only patch updates. And we can also use latest, which is going to get us the latest and greatest, for better or worse. Okay, now obviously as we are progressing through our development, at some point we want to start fixing into particular library versions to make sure that, hey, our build becomes reproducible the closer we get to production. So for example, if we're using Maven or Gradle in the JVM ecosystem, we want to remove the snapshot modifiers as soon as possible. As soon as those libraries have become properly released, we should get rid of that. So, keep that in mind. And this is a process that we have to do manually, which is a little bit of toil, but again, it is important. It is the price that we pay for the flexibility of being able to pull the latest version for that particular release. If we're talking about some of the other ecosystems, for example, in NPM, what we recommend is that you commit the package.lock JSON file, which is going to have the actual versions that were pulled down based on the rules that we specified. And if the package lock file is in source control, then we can use npm CI to download the dependencies exactly as they're defined in this file, as opposed to npm install, which is going to get the latest versions according to the rules that we have defined. So basically, developers can keep updating their packages. Once they're updating their packages, they should commit the package log file, But then on the CI server, to ensure that we have reproducible builds, we use the file that has the frozen in versions that we have been using. If we're talking about Python, pip actually has the freeze command that is going to generate the stable requirements txt, and we can use this requirements file in our CI server to make sure that we're using exactly the right versions. So, going through these processes, understanding how our build tools use the version rules, the versions that we can define, we can gain flexibility to be able to move faster as the libraries that we depend on are getting developed. But we also can get to the point where we can build reproducible builds that will make it a lot easier for us to debug, make it a lot easier for us to push changes into production, etc. All right, now that we have defined what our toolchain is going to look like, what dependencies we're going to use, let's talk a little bit about actually compiling the code. Obviously, this only applies to languages that are actually compiled, but nonetheless, let's take a look at it. And for this one, in general, what we want to ensure is that our build can be executed with the information that we have in source control. We want to make sure that we can build with that information without relying on external files or external settings or things like that. So what are the things that we control in source control? Well, what source files exactly are going to be compiled, the flags that we're going to use, any kind of pre-processor that we are going to have to execute, things like that. But the actual compilation depends on each language. And I'm not going to go into detail about each language. There's plenty of documentation out there that can show you how to build code for your particular language. But the important thing is, hey, let's make sure that the information that we need to compile is properly stored in our source control system. That will make our life a lot easier. It will help us, again, have reproducible builds, and it will make it a lot easier for new developers to get onboarded because all of the information that they need is already in source control. Similarly with tests. In general terms, we understand that code must be tested. And this testing must be ingrained within the build process. And testing is a very big topic, so we actually have a whole section on this that we're going to cover in the future. So stay tuned for best practices on how to run unit tests, how to run integration tests. But again, all of those things should tie back into the build. It should tie back into making life easier for our developers. During the build, there are other things that we can run other than just testing the functionality. For example, we can leverage tooling to ensure that our code is high quality, reliable, easy to understand, easy to maintain. And there are many tools that we can do this. Static analysis, formatting, things like that. Because what we want to do is we want to keep technical debt at bay as much as possible. Writing code is hard, but maintaining that code is even harder. So beyond testing the functionality of the code, we actually want to, leverage the tooling to ensure that the structure of the code, the way the code is written, make sure that we haven't introduced any fundamental bugs that could cause, security issues or things like that. So we leverage the ecosystem of the language that we're working on to run quality checks and quickly get a report of, hey, are we introducing technical debt? Are we introducing possible bugs? Things like that. And again, this is another very big topic, and we have a whole section dedicated to using tooling to ensure that we are producing the best code with the highest quality. All right, and we've gone through this whole process. We have defined all of this information, defined all of these processes. Why do we do this? Because at the end of the day, we want to have some artifacts that we're going to publish, and we want to make them accessible to the right people. And what are those artifacts? Well, for example, if it's a compiled language, the binaries that we built, whether it's an executable or a Docker container or a library that somebody else can import into their project. But we go beyond that. Some of the artifacts that we're going to build are, for example, reports. Reports about the quality of our code, the results of our testing, things like that maybe they're going to be consumed by other stakeholders, maybe they're only going to be consumed by our own team, but at the end of the day, they are important artifacts that will help us improve the component that we're working on, the application, whatever. So at the end of the day, we want to make sure that that information is available to the right people, even if the right people is our own team. For example, we could also put together documentation that we want to publish, things like that. And we're going to talk a little bit more about this in, again, future sections where we talk about continuous deployment and things like that, and some of the patterns that we can actually use to publish those artifacts, because these artifacts are normally not published directly by the users. They're normally published by a pipeline in a CI/CD server. But nonetheless, in many cases, the publishing is also part of the build process, even if it is a step that the developers will not run manually locally, but it is a step that it is coded there to be executed by the CI server at the right point. All right, so we've automated our build. Now what happens? Let's circle back and remember that one of the main reasons why we automate the build is developer productivity. Sure, there are other uses like the continuous integration server and things like that that also play a part, but one of the key objectives that we have to keep in mind is that we automate the build to improve developer productivity. So, now that we've actually automated the build, did we really improve the productivity of our team, of the peer developers that we're working with? That is the question that we have to ask ourselves. And, developer productivity should be an ongoing concern. One of the first things that we have to be concerned with is we want to protect the build. For example, are we preventing developers from getting a broken build when they do a git pull? How confident are we that they're going to get a working build? Do we have visibility into broken builds? For example, do we have visibility into broken builds on the CI/CD server? That one tends to be fairly straightforward. But do we also have visibility into broken builds as they're seen by our developers? For example, if they're failing in their local environments, do we have any kind of visibility on why or how often those things are happening? Those are the things that we should be concerned about as senior developers to ensure that our team is working as quickly as possible. Because let's face it, nothing kills productivity, nothing kills morale like having to debug a broken build. Follow these instructions, everything should work. You follow them, they don't even work. It really bogs down the uh, the cycle of our developers. So again, ensuring that our build is constantly green is one of the main concerns that we should pay attention to. There are many other things that we can try to improve as part of the automation of the build. For example, can we use a build cache to speed up the builds? And a build cache is something that is going to keep track of what are the inputs, what are the outputs of different steps in our build process, and it's going to create a cache of those from which we can pull and avoid doing a lot of the steps that have already been done by other developers or by other iterations of the CI/CD pipelines, things like that. So, this is supported by some tools, and they can greatly speed up the build of really large projects. Can we limit what is built locally? Can we split up the application into multiple modules to limit what has to be rebuilt every time? Can we limit what is tested locally? Making sure that the developers are getting good feedback in terms of whether their code is working or not, but without spending way too much time running their tests that might not be relevant to the changes that they're working with. Also, can we offload some tasks to remote executors? Compute tends to be a lot cheaper than the time of your developers. So sometimes it is better to add a little bit of extra compute, maybe in the cloud, maybe in some shared resource that the build can be configured to, so that some of the tasks can be offloaded to these remote executors. Those are all things that we can use to, again, improve developer productivity. Now, with that said, a lot of the things that we can do, we want to make sure that we're actually getting some metrics. We want to make sure that we are actually improving this productivity, that we're reducing the time that our developers are just sitting around waiting for the build to process. So the only way for us to really understand that is to get some metrics. Get metrics from the continuous integration builds. Get metrics from local builds. And, and if we get metrics that are showing a decrease in the speed in which we're doing any particular task, are we taking action of those metrics? For example, if our builds are getting slower, if we have the right metrics, we can start investigating why did this happen. Hey, did we add a very large dependency that is getting constantly pulled and is not getting cached properly? Is some of our caches not working as expected for whatever reason? Did we introduce something in the environment, for example, networking that is running slower, things like that? Did we change the artifact registry, the artifact repository that we're using, and suddenly this one is slower or less reliable, things like that? Did we upgrade some part of the toolchain and now we're having a different behavior, which is detrimental to the productivity of our developers? All of these are questions that we have to ask ourselves if the metrics show that there has been a decrease in the performance of the build, which we can infer is going to affect the productivity of our developers. Because as I mentioned before, the time of our developers is one of the most valuable resources in our team, in our organization, and it is our job as senior developers to respect that time. So with that said, the next thing we're going to talk about in The next video is how do we keep our team productive? Especially how do we keep them productive when we're working in larger projects where we depend on different moving pieces that might not be properly aligned. How can we ensure that our team remains productive despite all of the different moving pieces? Thank you for watching. If you enjoyed this video, please don't forget to subscribe. You can follow me on Twitter, you can follow me on Mastodon, or hit up my webpage, www.javaprocess.com. Thanks a lot, and see you next time.